Greetings, math enthusiasts. We are going to do some polynomial division today. So I am looking at the Algebra 2 6.5 homework worksheet. I'm going to do probably just the odds, and I'm going to start with polynomial long division. So notice that all of these on the first page, I've got a dividend, and all of my dividends are just quadratics, so the highest power is 2, and my divisor, the highest power is 1, so it's a linear term. So technically all of these could be done with synthetic division. And if you were given a choice, I would definitely choose synthetic division because it's faster, it's less frustrating, but we want you to practice the process of polynomial long division. So that's why they specifically ask you to do that. So looking at number 1, I'm taking the dividend m squared minus 7m minus 11 dividing by n minus 8. Remember that we look at this first term and we're dividing it into the first term of the dividend. I always write DMSB for divide, multiply, subtract, bring down, so that I can keep track of where I am in the process. So first is divide. I'm going to say how many times does m go into m squared? In other words, what times m gives m squared? So m times m I know is going to be m squared. So divide, check. Then just like regular long division, I multiply. M times m is m squared. M times negative 8 is negative 8m. You do have to multiply m by the entire divisor, the entire polynomial there. So multiply, check. The toughest part is subtraction because we have to remember to change all the signs, every single one. I'll go back to blue. Subtract, check. Well, actually, let's finish subtracting, then we'll feel better. This should always happen. Your first term you chose specifically so that it would cancel out. So now I've got negative 7m plus 8m is just 1m. Check for subtraction. And then finally, I bring down m minus 11. Check. So now I go back up to the beginning. I still am looking at this m right here. And I divide m into m. M times what gives me m? Well, that's just plus 1. So 1 times m is m. 1 times negative 8 is negative 8. So I've divided, I've multiplied, now I need to subtract. Remember, when you subtract, you change all your signs, every single one. M's cancel, negative 11 plus 8 is negative 3. Notice there's nothing left to bring down, which means that this is my remainder. And for our remainder, we could just say r negative 3, but for our polynomials, we're going to say plus negative 3 over m minus 8. So I take the remainder and I put it over this original divisor. You could also technically put my minus here, okay? But if I say plus a negative, that's the same thing as subtracting. So there's our answer. Our final answer for this question, number 1, is m plus 1 plus negative 3 over m minus 8. Usually we'll be okay if you just leave that right here for your final answer. Okay? Let's do the next one. Just more of these that you do, the better that you'll feel. Okay, so I've got n plus 5 dividing into n squared plus 10n plus 18. I'm going to look at this n. N goes into this first term. So n times what gives me n squared is n. Divide, check. Multiply. N times n is n squared plus 5n. Multiply, check. Subtract. I always put the parentheses in because then I actually remember to distribute my negative to all pieces. So every sign changes. N squareds cancel. I get 5n. Subtract, check. Bring down, plus 18. This check mark system really just helps me, like if I'm, what do I do next? That's usually the question. It's like, where do I go from here? This gives you an exact thing. Oh, I can trigger myself to do the next thing, do the next thing. Okay, so now I go back to the top, divide. What times n is 5n? That would just be 5. So 5 times n is 5n. It should always happen that those match. You're setting it up that way. Then 5 times 5 is plus 25. So I've divided, I've multiplied. When I subtract, make sure that we change all the signs. Okay, so the 5n's cancel, and I get negative 7. So now I have minus 7 over n plus 5. Notice I did it differently this time. You could have done plus negative 7 over n minus, or n plus 5. It doesn't matter which one. Okay, and I'm actually going to leave it here. So this is my final answer, n plus 5 minus 7 over n plus 5. Okay, just going to keep going so you see a few of these. Now I've got n squared minus 3n minus 21 divided by n minus 7. Look at this first term. N times what gives me n squared? That'll be n. N times n is n squared. N times negative 7 is negative 7n. So I've divided and I've multiplied. Subtraction. Subtract. Change all your signs. Your n squareds cancel. Negative 3n plus 7n is 4n. Subtract. Check. Again, this is the hardest step. Not the hardest, but it's the easiest one to forget, to make a little mistake on. And then bring down. Check. Okay. N goes into 4n, so what times n gives you 4n? It's just going to be the number 4, okay, because 4 times n is 4n. 4 times negative 7 is negative 28, so that's divide and multiply. Subtract. Change all your signs. You'll get 7. Okay, notice there's nothing else to bring down. So this last time, I can't do that. So what I'm going to make this is my remainder, plus 7 over n minus 7. When you're thinking about why we put a plus there, remember that terms have to be separated by a plus or a minus, because otherwise you'd be saying, like if I didn't have this plus here, I'd be multiplying 4 by all of this, and we don't want that. We want all of these terms to be separated, so that's why there's a plus. I think that's probably good for our polynomial long division for now. Definitely try the rest of these. Okay, so try those evens, and then let's move on to our synthetic division. So remember, synthetic division is specifically when our divisor is a linear term. So again, that whole first page could have been synthetic division, but we just wanted you to practice that process. But synthetic division is it's kind of like a simplified version of long division. So if you recall, my coefficients of my dividend are going to go just lined up horizontally. And if it helps you, you can put like an x squared, an x, and a constant here just so you're lining yourself up. And then your box number, remember, is always whatever makes this divisor 0. So you can say x plus 2 equals 0. What's the box number going to be? We'll subtract 2 on both sides. And the box number is negative 2. So I'll put that right there. The other thing that I always write down is that this original is a degree 2 polynomial. That means the highest power is 2. When we divide, we're going to knock every power down by 1. Okay. So we are always going to add above the line, multiply below the line. So notice the 3 is above the line. There's nothing to add it to. So 3 plus 0 is just 3. And then when we multiply, we're always multiplying by the box number. Okay, so negative 2 times 3 is negative 6. Then I add, 7 plus negative 6 is 1. Then I multiply, negative 2. And I get, oh yay, I get a 0. So notice, this is a degree 2. That means that this one is a degree 1. And that's because really I'm taking this x and I'm dividing the x squared by x. Okay, so then I'll just get an x term. I'm dividing the x by x, so then the x's will go away and I'll have a constant. And then dividing by the 2 would give me my remainder. So this degree 1 polynomial is really, my answer is 3x plus 1. That's my final answer for my division. Okay. Again, what that means is, and here's where we're going, that means that 3x squared plus 7x plus 2 is actually equal to 3x plus 1 times x plus 2. Okay, we know that that's true because we had no remainder. That's why it's so nice when we end up not having a remainder. All right, let's do a few more. Number 3. So I have 7, negative 3, and 5. Notice I'm keeping all of my signs. So I've got a positive, negative, positive. What makes this 0 will be negative 1. Okay, it's always going to be the opposite. I'm going to write over here that this is a degree 2, which means that my answer It's going to be knocked down by 1 power, so it's going to be a degree 1. Okay, and then I'm going to add above the line, multiply below the line. So bring down the 7. Negative 1 times 7 is negative 7. Add, I get negative 10. Multiply, I get 10. So this time I actually have a remainder. I always circle the remainder, and then if there's no remainder, I put a smiley face in it. But that means that this reminds me that this is going to be the fractional part. Okay, so this is degree 1, so my answer is 7x minus 10 plus 15, and then it's like over what? Well, think back to polynomial division. We always put it over the divisor, so x plus 1. So there is my answer. Okay, notice I started with an x squared, so that's why I get an x, because I'm dividing by something that has an x. X squared divided by x is x. And then I knock down my powers from there. Okay. Number 5 is interesting because notice it looks like maybe it's a degree 2 polynomial, but the highest power is actually a 4. So because the highest power is actually a 4, this is a degree 4. This is where writing your x to the 4th, x to the 3rd, x squared, x, and constant can help you keep things lined up. Okay, so I know I'm going to have a box number. Specifically, it's whatever makes this 0. So x plus 2 equals 0 means that x is equal to negative 2. And then my coefficient on the x to the 4th term is negative 1. Notice there's a negative with it. And then negative 2 for x cubed, 3 for x squared, 4 for x, and negative 4. That's a lot of numbers, but it's going to work just the same. Add above the line, multiply below the line. So bring down the negative 1, multiply, get 2, 0. Multiply, negative 2 times 0 is 0. Add, negative 2 times 3 is 6. Add, I get 10. Negative 2 times 10 is negative 20. And then I get negative 24. So that's my remainder. So now we've got to think, because it's not just what we've done every single time, this was a degree 4 polynomial. So if I knock everything down by 1 power, the highest power is actually going to be a degree 3 polynomial. So that means that my first coefficient, negative 1, is on an x cubed. And then I have 0 x squareds. Then I have 3 x's, 10 for constant, and then negative 24 is on the remainder portion of my polynomial. So I put x plus 2 in the denominator. Good morning. Okay, so now we're going to move on to where synthetic division really gets its power, and that's when we're given 1 0 and we can find some more zeros. So looking at number 15, I have this function, this polynomial, and I'm told that a 0 is x equals negative 3. And the funny thing is that this is actually a typo. The real 0 is x is equal to negative 2. But the big thing here is if you're given a 0, then we know that this is a good box number, absolutely. Okay, so that means that I'm going to get a remainder of 0 if I use negative 2 as my box number. So I'll have 9, 10, negative 17, and negative 2. But then I'll do synthetic division just like normal. So I bring down the 9, multiply, and get negative 18. Add, negative 8. Multiply, I get 16. Add, I get negative 1. Multiply, get 2. And then I add, and yay, I have a remainder of 0. So originally, this was a degree 3. My answer must be a degree 2. So I have 9x squared minus 8x minus 1. Okay. But what this really means is that f of x, my original function, is 9x squared minus 8x minus 1, but then it's also times x plus 2. Notice it's x plus 2 because my box number was negative 2. So what they want to know is what are the zeros. So I can set 0 equal to 9x squared minus 8x minus 1 times x plus 2. Okay. Since I have something set equal to 0, I can set each one equal to 0. And of course, I'm going to get x is equal to negative 2. Okay, we set ourselves up for that one. And then the other one I can solve by factoring. I can solve by quadratic formula. Just as a reminder of quadratic formula, that's what I'll do. So x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a will be x is 8 plus or minus the square root of 64 minus 4 times 9 times negative 1 all over 2 times 9. Okay, so that is 8 plus or minus 64 plus 36. Take a second and confirm that for yourself. 4 times 9 is negative 36, and then times negative 1 is positive 36. That's actually the square root of 100 over 18. So 8 plus or minus 10 over 18. Okay, so that means that one of our answers is 8 plus 10 over 18, which is 18 over 18 is 1. My other answer is 8 minus 10 over 18, which is negative 2 over 18, or negative 1 over 9. Okay, so now I have all my answers. I have x is equal to negative 2, x is equal to 1, and x is equal to negative 1 over 9. Notice that I've got 3 answers, and that's because my original polynomial was a degree 3 polynomial, so that will always happen. Okay, so it's kind of a longer example, but you can see that your synthetic division will help you to find your first answer, and then you can use all of the other tricks that we know for a degree 2 polynomial. So that'll be factoring, that'll be completing the square, and that will be your quadratic formula. Okay, so let's try just one more of these. Let's look at number 19 this time. I have f of x equals x cubed plus x squared plus 2x plus 24. And I'm told that x equals negative 3 is a 0. Again, that means that this is a good box number. Okay, so I'm going to put my negative 3 here. I've got 1, 1, 2, and 24. I bring down the 1. Okay, so I add above the line, multiply below. So negative 1, or negative 3 times 1 is negative 3. Add, and I get negative 2. Multiply, I get 6. Add, I get 8. Multiply, I get negative 24, which is exactly what should happen because we're told that this should work, that I should get a 0. Now again, this started out as a degree 3 polynomial, so my new polynomial is actually a degree 2 polynomial. Okay, so that polynomial is x squared minus 2x plus 8. But because this worked out so nicely and there was no remainder, that actually means that my original polynomial is equal to this x squared minus 2x plus 8 times x plus 3. And remember that x plus 3 is because of the box number, okay? Because when I have x plus 3, the box number is negative 3 because we set it equal to 0. So now I've got this, and I'm asked, actually, the final question is you're asked to find the zeros. So I say x squared minus 2x plus 8 times x plus 3, and I set that equal to 0. Okay. Now we know that when I have something set equal to 0, I can actually set each piece equal to 0. And that's from chapter 5. So one of these works out perfectly. I subtract 3 from both sides, and I get x equals negative 3. That's what we were told was true, so we shouldn't be surprised by that at all. And then I look at this one. The first thing I think about is, can I factor? Okay, so if I could, I would add multiply, but I would need a negative 4 and a negative 2, a positive 4 and a positive 2, negative 1, negative 8, or positive 1, positive 8. None of those add up to negative 2. So that doesn't work. So instead, I could do completing the square, I can do quadratic formula. Just as a reminder, I'm going to do quadratic formula. So first thing, subtract 8 on both sides. So I'm going to get x squared minus 2x. I do plus blank is equal to negative 8 plus blank. Okay. So now I'm trying to figure out what goes in that blank. So I take that middle term b, divide it by 2, and square it, and I get 1 in both of the blanks. So the left side, we've set this up so that it'll factor nicely. X minus 1 squared is equal to negative 7. And now we solve. Take a square root on both sides, and I get x minus 1 is equal to plus or minus radical negative 7, which, if you remember, is radical 7 times I. Okay, I can add 1 on both sides. I get x equals 1 plus or minus radical 7 times I. And those are my answers. Okay, notice that I've still got 3 answers. Okay, I have x equals negative 3, x equals 1 plus radical 7 I, and 1 equals, or x equals 1 minus radical 7I. So I still have 3 answers, but technically I have 1 real solution and 2 non-real solutions. And we'll talk about what that means next time in terms of real and non-real zeros and places where I cross the x-axis. But these should be the same skills that we saw in Chapter 5. Okay, so the first thing you're going to do is use synthetic division to get it down to a degree 2 polynomial, because we know what to do with a degree 2 polynomial. We can use the quadratic formula, we can complete the square, or potentially we can factor depending on our problem. Okay. So that's our polynomial long division, our synthetic division, and then finally our synthetic division to find zeros. So keep practicing on this. Do numbers 16 and 18. See how it goes. I hope your studying goes well for this, and we'll see you next time.